for using a round bottom flask, so you can actually use standard open vessel glassware. So this is actually provided by us, but you can use pretty much any extender. And then this was your own round bottom flask. So there's a couple steps you want. So the equipment you need is obviously your flask, and then you have, this is a little stand, so the vessel actually stands on here. It has two holes in the bottom. This hole is for the temperature measurement from the bottom of the cavity. This is for the cooling air. So the cooling air will also work on the open vessel as well. So what I usually do is I will put the disc in. Here, I'll pull it out so you can kind of see. And then you'll want to line up the holes there.
Okay. Is that...
Yeah. So everybody can see. And then once that's placed in the system, you place your flask. Usually I recommend the extension glass. And then this is the open vessel attenuator. It's pretty easy to distinguish between, because it's the silver as opposed to the black. And then you'll place that down over, lock that in place, and then the system will know that you're doing an open vessel. Now, again, I say that because the system does know if either there's no attenuator in place or if there is the open vessel. So the pressure device is not going to move forward and damage it. So there's no other settings you need to worry about. It's all taken care of there. So you can kind of see right here, actually. I don't know if you want to try and get a video of that. It may be, okay, that's actually pretty good. So if you, no, go back. So if you see this little symbol on the bottom in the middle, changes to door open. And then if I use the other attenuators, it'll change again to U, which is basically a little vessel symbol, 35. So as I mentioned, the system knows what's going on, what you're using. But again, from there, once the open vessel is attached, any kind of extender glassware or standard glassware you wanted to use, reflux condenser, slank line, anything like that, can be added right from there. So the only trick is make sure that you're using the stand when you are using the vessel, and make sure you remove the stand when you're done. Not going to cause a ton of problems. It is just a Teflon, so it's not really going to absorb a lot of energy, but this may absorb some of the heat of your other reactions, and it's also going to potentially cause some issues with like the camera and things like that. So like I said, just try to make sure you, whenever you're starting the reaction, everything's clean inside, and then go from there.
Will you see the flask with the camera?
I don't. Oh yeah, the flask, absolutely. So I apologize. I know it's hard to. So that's hard to tell. Excuse me.
This is the bottom of round
But
bottom.
yeah. But if I had a stir bar in there and you had liquid in there, but you can see me moving it kind of.
Oh, you don't see
If
the
you have
screen.
solvent
Yeah.
like
Yeah.
software or something. you can-
Yeah, certainly. You'd be able to tell there's something going on.
So now, like when we are using a vessel, we can't open it like because it will give us warning if the pressure is high or temperature is high, right? So what if when we use this one?
So that is something you need to be aware of, just like your standard reaction. Obviously, open vessel reactions are going to be inherently more dangerous in the sense that whatever temperature you set it at, it's going to try and reach.
Okay.
But if that's way past the boiling points of your solvents, it doesn't really care. It's going to keep trying to heat it. So you would need to be a bit more aware of that. And again, that is one of the downsides, obviously, of the open vessel is you still can't move past ambient temperature. The pressure is not going to be held here. But it still is going to allow you to heat considerably quicker. And again, for some of those reactions that sort of just interact very well with the microwave, you're still going to see some increased results by being able to do that.
So it won't monitor the pressure?
The pressure, no, because the pressure is being monitored by this device.
Oh,
And so since it doesn't move forward, it's just going to be worrying about temperature. Yeah. But yeah, fair question. So from there, I will discuss the gas addition kit, which is a bit more bits and pieces, but otherwise functionally similar to what you're doing. So Okay, so